Oh, Kapoy, you left that in here, so you see it? Okay. All right. So, here's the deal. Look at the number. What number are you on? The last quarter of Algebra 2. Assignment number 1. Starting over for the last time. I know. It's so sad. What? Okay, you have to wait till after. I mean, you could have come in to tutorials and asked at any point, but right now, wait till after. Okay? So, here we go. Today should be nice and easy. Okay? We saved an easy topic for right before spring break. We are going to solve with common basis. So, think back to Algebra 1. Do you remember what you do if you have an exponent raised to another exponent? Okay, you would add if it was this. But if there's only one base, you multiply. Okay, so in this case, you would have added, but since it's an exponent to an exponent, you're going to multiply, so it'd be like this. Okay? So if there's only one base, then you multiply. Okay, now what about a number, any base, to the power of 0? Not 0. 1. Good. Okay, and then if you have a base that doesn't have a listed exponent, that's the same as like if it's b to the 1, right? So you don't write like x to the 1, but there's only one of them, right? Okay, then the last thing, if you have a fraction with your exponent on the bottom, you are allowed to bring it to the top if you turn that exponent negative. Okay? So any term that's in the denominator of a fraction, you can move it up and turn the exponent negative. Okay, now you have this giant chart. I don't want to spend a lot of time on it. We're going to fill it out. Okay, but we're going to just go one by one. So ready? What's 2 squared? Because that's 2 times 2, right? Okay, now multiply by one more 2. What do I get? So then 2 cubed is 8. Okay, 2 to the 4th is times by another 2. What do I get? Okay, then times by a 5th 2. 32, right? Because I'm just multiplying another 2. And then last one is 64. Now, could you, if you like this better, do 2 up to the 6?
Yes.
Sure, that's fine. Okay, up to you how you like it better. It doesn't matter to me. Okay, 3 squared is? Times by 3 again? Times by 3 again? So your 3 chart should be 9, 27, 81. Okay, do the same thing for 4. 7, 81. Okay, so 4 squared is 16. Times by 4 again, what do we get? Nope. 64, good. And then 64 times 1 more 4 is 256. You don't have to do this in your head. We're just, you can use your calculator. Okay, so 5 squared, what do we get? 25. And then in my calculator, I'm going to do 25 times 5. And then I'm going to, oops, I wrote the wrong thing. 25 times 5, and then I'm going to times that by 5. So it'll be 25, 125, and 625. Okay? 6 is the last one that we're going to do all 3 of. So 6 squared is 36. 36 times another 6 is 216. Then times by 1 more 6. 1296. Now look how big that bottom row is getting. We're just going to cross them out. You're not going to end up ever really using those. Okay, so now let's do our 7. So 7 squared is 7 times 7. Okay, what about times 1 more 7? 343. Okay, next one, 8 squared is 64. And then what's 64 times 1 more 8? 512. Okay, next one, 9 squared is 81. Okay, now, do you notice that the next 9 is missing the little 3? So just write it in. 81 times 9 you said is how much? 729. Okay, good. Now, the reason that we're making this chart right now is so that you don't have to ever make it again. Okay, so just keep this piece of paper so that you don't have to make this chart again. Last one, 10 squared is 100. Then 1,000. Then times by one more 10, it'd be 10,000. Yeah? Okay, so now that you have your chart, here's what we're going to do with the chart. You're going to use the chart to get a common base on both sides. Now, do you remember when we were getting common denominators on both sides? What did we do after we got a common denominator? We canceled it out. It's the exact same thing here. You are going to convert to get a common base. Okay, and then I'm going to put a little star here. You're going to use the chart to do that. That's why we made the chart. And then after you get a common base, you're going to set the exponents equal to each other. The reason that you're allowed to do that is that the common bases are going to cancel on both sides. And I'll show you what this looks like in a second, but just so you have steps. So you're going to cancel out the common bases, then you're going to set the exponents equal, and then you're going to solve. Okay, this is much, 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 much easier than the unit that we just did. Okay, so take a look at number 1. Do they already have a common base? Yes, what's the common base? Then I can cross it out. What's left over? 2x equals 10. Then what do I do last? X is 5. See, look, it didn't take 100 years like all the stuff we've been doing the last 2 weeks. Okay, now take a look at number 2. Number 2 does not have a common base. We're going to use the chart to fix it. So look in your 2 chart. Now, let me answer this question. On this side, I have a 2. That's how I know to look in the 2 chart, is that I need them to match. Okay, so do you see right here? What is 64? So I'm going to write 2 to the 3x is 2 to the 6. And I'm going to convert that using my chart. Cross out the common 2's. So 3x must then equal 6. Then divide by 3, x is 2. Okay? So you're going to get a common base using your chart. Cancel out the common base, set the tops equal. Now take a look for me at number, let's skip 3 and go to 4. We'll come back to 3 though in a second. Okay, take a look at number 4. I have a 2 on one side, I have a 4 on the other side. You're always trying to convert the bigger number to the smaller base. So look in your 2 chart. What is 4? 2 squared. So on this side, I'm going to make it 2 squared. And then the old exponent that was already over there, you're going to group it in parentheses. You're going to have to distribute. That's exactly right. So when you convert the 4 to a 2 squared, you're going to keep the old x minus 3 together. Cross out the 2, just like we did previously. And then you're going to have to distribute at the top there. So, so it'd be 2x, and then 2 times minus 3 is minus 6. Okay, so we're going to add the 6 on both sides. 10 plus 6 gives me 16. And then I'll divide by 2. That's where the 8's coming from. Good job. It's okay. Got it? Okay, now let's go back to 3. So what base do I need 49 to be for it to match the other side? 7. So I have 7 to the 2x equals. Okay, then I'm going to look in my chart. So look right here. Okay, 49 is here. That's 7 to the 2. So I do 7 to the 2, group the x plus 3. Because remember, x plus 3 was already up there. Okay, I cross out my common 7's. And I end up with 2x on the left side. And then on this side, I end up distributing. What do I get over there? Okay, then I want to bring the baby to the mama, but here's the problem. They're both the same, right? They're both 2x's. So when I minus my 2x across, What happens when I get 2x minus 2x? I get 0 equals, and then what's 0 plus 6? 6. So it would be what? Is it infinity solution or no solution? No solution. Okay, now let's review how you can tell. If all your x's cross out and you're left with something that's true, it'd be infinity solution. But if you end up with 0 and 6, those are not really equal, so you would say, actually slash that out for me. Okay, 0 and 6 are not equal, that's why it's no solution. Okay, come down to number 5. Number 5, we're going to use one of our special rules. If I want this to be a 1, look back up to your rules here. If I want it to be a 1, what exponent do I need? A 0. Now, notice that this b can be any number. If I want to have a common base with the other side, what base do I need to use? 9. So look, watch. I'm going to put use b to the 0 to replace a 1. So this is what I mean by that. On the one side, I'm going to keep it a 9 to the 2x minus 6. But on the other side, if I want a 1, I'm going to make it 9 to the 0. Now, if you don't believe me, look, I'll type it in for you. It doesn't matter what base you use. Okay, I'm sure you do believe me because I'm your math teacher. But 9 up to the 0 is 1. Okay, you could do as many numbers as you want. Blah, blah, blah. We'll put a pi in it. Okay, up to the 0, it's still going to be, and then just don't look at that, okay? But the point is, it's because I didn't put a times. Hold on, I'm going to show you now. Don't worry. I didn't lie to you. Okay, and then we have to give this one its own 0. Okay, I picked something too complicated. Okay, but now look, if they both have a 0, what do you get? 1. Okay, it doesn't matter what the base is, you always get 1. So you match the base with the other side and then do what? Cancel them out. Okay? So then from there, I have 2x minus 6 equals 0. Okay, so the minus 6 moves over as a positive 6. Good, then divide by 2x is 3. Good? Alright, turn over to the back. See, aren't you glad these problems don't take up half a sheet of paper like the other ones? So nice. Hey, Sean. They're on the top. The very, very top. Yep. All right, look at the next one. Okay, we need to match our bases. So I have 6 to the x to the 4. Remember that that is the same as 6 to the x group the 4. Okay, and then on the other side, you may need to flip over. What is 36 as a base 6? 6 squared. Now, but what was already there? The 8. And remember that if they're both exponents, you are multiplying those together. So when I cross out the 6's off both sides, 4x on the left, and 2 times 8 is 16 on the right. Divide by 4, divide by 4. 16 divided by 4 is 4. Good. Okay, other side, take a look at it. We have 2 to the x minus 1. I'm going to group that together with the 3 on the outside. And then on the other side, I had an 8, but I need to convert that. Use your chart. So flip back over. What is 8 as a power of 2? 2 to the 3. Okay, and again, if you don't remember where that came from, look. Here's 8, 2 to the 3. Those are the same. Okay, so from there, I cross out my base 2's. And then I'm going to distribute the 3, but instead of distributing from the front, it's like you're kind of back distributing, but it's the same thing. Okay, so 3 times x is 3x. 3 times minus 1 is minus 3. Then from there, you're just going to keep solving. If it's a minus 3, I have to plus the 3 across. Okay, good. So I get 3x equals 3 plus 3 is 6. Divide by 3x is 2. Okay? No extraneous solutions for these. You don't have to worry about that. Okay, the last 4 examples, what do they all have in common? They all have fractions. Okay, so flip back over to the front. Which rule had a fraction in it? The last one. What did we do to the exponent when the b was on the bottom? We turned it negative. So look at number 9. It's 2 to the x equals 1 over, and then what is 64 as a base 2? 2 to the what? Look at your chart. 2 to the 6. Okay, but because 2 to the 6 is on the bottom, I can't use it like that. So when I move it up, what's going to happen to the 6? It'll be a negative 6. Very good. So I'm going to use a negative exponent to remove the fraction. Okay? So when you turn the 2 to the 6 to be a 2 to the minus 6, it's not a fraction anymore. That's how you get rid of the fraction, is you turn the exponent negative. Then the 2's are going to do what? Then x equals what? Now, most of the time you would have another step or two to solve, okay? But in that case, all that's left is x equals the number, so you're done. Okay, go down to number 10, please. Next one. This time I have 16. What is that as a base 2? Now, it's 1 over 2 to the 4, so how could I change it? 2 to the negative 4. Okay, and then what was already on that side that I can't forget about? The 5, so parentheses 5. Okay, but again, where did the negative come from? It had been a fraction, right? Okay, then other side is 2 to the 4x. Okay, when you get those to match each other, you can cross out the base 2's. Negative 20, because remember, what do you do with the numbers when they're both up top? You multiply. So negative 4 times 5 is negative 20 equals. Okay, good. Then I'm going to switch it around because I like to keep x on the left. But if you're fine with not doing that, that is okay with me. And then I'll divide. So I switched it around, and then I divided by 4. X is negative 5. Okay, look at the next one. Use your conversion chart. We need to now turn, what base do we want 64 to be? It has to match. Okay, if this side is a 4, then I need to turn the other side to a 4. So look at your chart. What power is 64 as a base 4? Okay, very good. This is going to be 4 cubed. Okay, however, where is 4 cubed? It's on the bottom. So in order for me to move it up, I have to make it a negative. Good. So 4 to the minus 3. And then remember that right here, all I'm doing is I'm taking the parentheses and I'm grouping the guys that were inside. Okay? So 4 and 4 are gone. 2x minus what? Minus 2. And then equals minus 3. And then from there you just keep solving. So to get rid of the minus 2i plus 2. Negative 3 plus 2 is negative 1 on that side. And then last step, if it's a 2x. So I get x equals, my 2's cross out. Oh, why did I put 2 x's? I don't know. Negative 1 divided by 2 is negative a half. Okay? Or if you want to put negative 0.5, that's okay. Okay? No problem. Alright, there's one more left. Now, what I want you to notice is that all of the ones that had fractions, how did the answer come out? Okay, it was negative, negative, negative. Okay, so in this last one, let's see if that pattern stays the same. On the left side, I have a 9. What's that as a 3? 3 squared, but it's on the bottom, so it's 3 to the negative squared. What was already on that side? X, keep it in parentheses. And then on the other side, I had a 3 to the minus 8. Cross out your base 3's. And then on the left side, I have a negative 2x, but then it's equal to a negative 8. What's going to happen? And when I divide a negative 8 by a negative 2, what do I get? Positive 4. So be careful about, even if it starts off negative, there's a chance that that negative could cancel out at some point. Okay? Yes. Okay, so I'm going to give you 2 to try right now, and then you'll have the rest of class to finish. Let me grab. Okay, I'd like for you to give number 7 and 11 a try. 7 and 11. Okay, remember the conversion charts at the top of the notes, that's what you're using to change them. So 7 and 11. Huh? Uh-huh. Yep. Which one? Oh, okay. All you have to do here is just, if it's squared, I would just write it twice. And then just double distribute.
Oh, okay.
And then it'll just be a normal power rule, and you can just do the integral as usual.
Oh, okay.
Okay? So the negative 5's cross out. Huh? When we're done, we're almost, we have 2 more left. Okay, you get 2x minus 12 equals 24. Uh-huh. Okay, so 12 plus 24 gives me 36. Last step, what do you do from there? Divide by 2, x is 18. Good. Okay, last one I want to do together. Look at number 11. Okay, so number 7 was kind of easy. Number 11's a little bit tricky. If you look at your chart, can 27 be written as a 9? No. That means that you're going to have to change both sides so that they can match. So look at all your columns. What 2 numbers can 27 and 9 both meet at? They can both be a 3. So here, I'm going to need to use base 3. And the reason why is because 27 can't be a 9, and 9 can't be a 27, but they can both be 3s. So on the left side, 27 is 3 to the what? And then on the other side, 9 is 3 to the 2, but I have to make it a negative 2 because it was a fraction. Okay? Then from there, my 3's cross out. Go ahead and finish solving it. It's going to come out to be a fraction. This is the only one I think that's a fraction, other than... Okay, so 3x minus 3 on this side. What'd you say? Okay, I'm going to add the 3 across. Is it a positive or a negative 1 on the other side, though? Okay, so 3x is positive 1. Then I divide by 3. So it's 1/3, correct. Okay? Any other ones? Glance over it that you think we need to do? Girl, bye. Do y'all remember how to get the 1? What base do you use? Okay, good. So I'm going to put here, make sure you use b to the 0. Now, remember, what base are you going to use if you're wanting to cancel them out? Say on number 8, you'll have to use a base number 8. You'd have to use a 12 because you have to match the one on the other side. So like, for example, if I was setting this one up, it'd have to be 12 to the 0. Because you could pick a different number, but if you pick a different number, they don't cross out. So that's the purpose of using the 0 exponent, is that you can use whatever base you want and they'll match each other. Okay? So look right directly above that at number 5. What base would you need to use on that one? 5 to the 0. Because these have to match each other or else they're not going to cross out. So up here I'd have 5 to the x minus 2 times 3. And then on the other side, I'd have to match this base. So if it's a 5, it'd be 5 to the 0. Okay? Alright, so here's the deal. Today's the last day for you to turn in makeup work. If you have makeup work, I'll take it right now through the end of the period. I'll be here till 5 after school. If you need to stay and work on anything, that's totally fine. I should have your CBA reviews, part 1 and part 2. Okay, if I don't have them, then you can come talk to me right now while everybody's finishing. I'll leave the answer key up here for you to check it if you need to. Okay, the only thing that you should be turning in to me tomorrow is a CBA review if you were absent. Other than that, I'm not accepting stacks of like homework 3 from 2 months ago. Okay? Good. Okay, so do your homework. You can come check it here in a minute.